Good afternoon, my fabulous chemistry students. Start of Unit 3, Periodic Table. Today is video 1. We are going to delve into the history of the periodic table. Basically, when you are done with today's video, I want you to be able to tell me the two scientists' names that are credited with creating the periodic table and why and what they did. Okay? So we might say to ourselves, hey, how were all the atoms originally arranged? Well, they were originally arranged by their masses, as we're going to find. And now it's come to be by their atomic number, as we learned last unit, and governed by this law of periodicity. So here is your first Easter egg. On the bottom of the screen, it says text this number. And for me, period 4 with @milks and period 9 with @milks9. You sign up for this. Everybody that signs up for this tomorrow gets a STEM buck. Easter egg number 1. And on with notes. Here we go. Chemical periodicity in the history. So Dmitri Mendeleev is how we say this. Was the first chemist to kind of mess with the atoms and try to put them together. And he chose to put them by mass. So unfortunately, this resulted in what we call gaps and these intervals being out of order. And you can see the gaps in the graphic, right? There's some big holes in this thing that don't really make sense. And if you look at the numbers, they're not going up perfect. But this was the first try at it. Later, Moseley started to use these very cool X-ray spectra to prove the existence of the proton. And then he decided that, well, let's rearrange this thing by the atomic number. Now this is more what you and I note, and we've been using the past unit, and what we're going to delve into today. And notice, it is 1, 2, 3, 4. It's set up by protons. So as the number of protons increases, our elements are going to move, or we're going to come up with a new element. So periodic law, the elements in the periodic table are, of course, periodic functions of their atomic number. Periodic happens periodically. Periodical. Well, that's the newspaper, isn't it? And it comes out every day at the same time, periodically. Basically, all this states is, as far as atoms, as we move across a row or a period, we are going to add one proton into the nucleus and one electron to the valence shell. Remember, valence means outermost. Okay? The maximum number of valence electrons, anybody remember? 8. Therefore, an element with 8 valence electrons makes the end of the row or period, right? And then at the new one, we will have 1 valence electron when we restart on the left-hand side. And it's going to repeat like this, and repeat, and repeat, and repeat. And this is what gives us our periodicity. All right? So the number of valence electrons dictates the number of bonds an atom can make. We'd learned that. Okay? And the number of bonds an atom can make is going to give it its chemical properties. As I move down a group or column, we call them groups, we add a principal energy level. So that's like adding on that extra coat full of pockets to stuff electrons in, right? Or we can call it an electron shell. Either one is fine. But you're going to find as we move down, no matter where we start, left-hand side or right-hand side, if I move down, I'm adding energy levels. So all elements in the same column or group have the same number of valence electrons. This is going to make them do the similar kind of things, okay? And the same column or group is going to have similar chemical properties. There we go. We have completed our notes for the first section. That was pretty quick. I need you to recognize Mendeleev and Moseley as our two major chemists, right? Mendeleev started it. He's Russian. Did it by mass. Moseley did it by atomic number. You can now complete your practice packet, pages 1, 14, 25, and 29, all right, with just this information. And don't forget to sign up. You get a STEM buck. I'll see you guys tomorrow.